Hello everybody, welcome to the Poly 101 demo video. In this video, I'll show you the fundamentals of PolyAPI that you would use to implement these 5 use cases. I won't get into the use cases today, but if you're interested, go to our website and check them out. I'll show you the out-of-the-box functions that Poly comes with, and then I'll show you how you can add your own functions, both using Postman and importing OpenAPI specifications. Next, I'll show you how to use the AI assistant to consume those APIs. And then I'll go ahead and show you how you can write your own custom functions. We're also going to write a new microservice, which is used in other use cases, for example, inside the service development. And I'll also show you how to use client functions to abstract out reusable code. We'll use variables to make sure that access to the underlying system is secure. And we're going to use webhook handlers to expose new endpoints that could be used by others. So let's dive in. First, let's start with the catalog. Here you can see your catalog of primitives that you have in your tenant of Poly. More specifically, there's a concept of environments, which you could think of as subtenants or projects. In this environment, we don't have any API functions. But we do have public functions that we can take a look at. So for example, if I was interested in integrating with Opera Cloud, I could do a search for example, OHIP. And we could see there's lots of different functions available from OHIP, multiple pages worth. Each of these functions, for example, getting the details of a profile, has a name, a context, which you could think of as a tree structure classification. It's got a description. We could see that it's made public by the Poly system tenant, so you could see the origin tenant it's from. You could see what arguments it expects, and you could see how this API structure happens behind the scenes, and you could also see what you're expecting to get back. So first thing to note is that there's a public catalog with lots of different providers that you can take advantage of right away. For example, I might do a search for adyen.payment, and we can see that these are the endpoints I could use for interacting with payments. So it's multiple systems, their respective functions, all available in one place. And if I wanted to, if I had it ready, I could also execute these functions directly from the console. So here we could see the arguments it's expecting, and you would populate that and then hit execute. I'll show you that in just a minute. We'll get to the other primitives later, and some of them we won't cover today just because this is an intro. So let's focus on just the most basic ones. We'll start with the API functions. Right now, in our environment, we don't have any, so let's go ahead and populate some. First, I'll show you how to use Postman to populate it, and then I'll show you how to use OpenAPI specs. So let's switch over to Postman and train our first function. Here, I have prepared an API request to the Google Maps API. I've set the location as Disneyland, and I've also populated my API key, and I'm using environment arguments inside Postman for a reason. So I'll show you how that factors in just a second. I can go ahead and hit send. We can see that the results come in from Google, and we can also see in the console that in addition to making the API call, we are now training this function. It's made a second call to the Poly endpoint, and that the function has been trained. What this means is that this information was captured and passed to Poly. Poly ran 2 algorithms on it, one which is programmatic to interpret and understand and model the request, and a second algorithm which is AI driven to name it, describe it, and classify it. I'll show you that in just a second. How this works is you have a set of training scripts that you can choose to add either to a request, you can add them to a collection, or you can add them to your entire workspace. And those training scripts is what does the handling of that data and passing it up to Poly using your key for security. So now that I've completed this, let's go back to the catalog and take a look and see how this API function looks in the Poly UI. So here we are. I'm going to go ahead and hit refresh, and we can see that we now have this function. By the way, there's also a dark mode, so you can go ahead and switch to that. I like to use this mode, so we'll just go ahead and continue the demo in this mode. So here, let's go into the function. We can see that the name was set get by address. The context was Google Maps geocodes fetch. It wrote a description for it, for what this function does. It set it in my environment. You can see the arguments it's modeled out, location as a string, an API key also as a string. Again, we could see the source of what that call looks like. And we could see that it returns an object with the following return type schema. So all of this was built programmatically by interpretation through observing that API call. Similarly, we can go ahead and make that call if you'd like, but let's go ahead and dress it up a little bit just to show you that you have full control over these functions. So we'll go ahead and hit update, and I don't love the name. I'm gonna say I want it to be called search by location, okay? And you can see the context, Google Maps geocodes fetch. I think the fetch is redundant, so I'm gonna go ahead and remove that. And with the rest of it, I'm happy. I'm gonna assign myself as the owner, and we'll go ahead and hit submit. Now, I'd like to show you another feature called variables, and this is for handling configurations and credentials and things of that sort. So, for example, I'm going to go to variables. We can see I already have a lot of them from other demos, and I'm going to go ahead and hit create. And let's go ahead and name this API key. We'll do credentials, Google Maps, and then the description, we'll leave it blank, and then the AI is going to go ahead and populate it for us. Don't worry, the AI doesn't see your credentials. It just bases it off the name and context if it is a secret. We'll mark it as a secret. We'll say it's a string. I'll go ahead and populate that. And then if this credential expires, you probably want to put an ISO time here to remind yourself. In the future, we're going to have alerting and other mechanisms to help you out. But for now, at least you want to be able to remember when it expires. So what I'll do next is I'll go ahead and put my key in here, and I'll hit submit, and then I'll see you there. All right, so I've pressed submit. We can see a description was generated. You can't see the value because it's a type secret. And so now we have a credential. So now let's go back to that function. We can see we have it here, search by location. I'll go ahead and hit execute. For the location, I'll go ahead and say Coors Brewing, Golden, Colorado. And for the API key, I could either paste it in here, or I can reference a variable, and then I'll just search for Google. Oops. I'll search for Google again. There we go. And you can see I've got that credential. I can select it, hit execute. And so now what we're doing is we're making a call to the Google Maps API through Poly, through the gateway, outbound gateway, and we're using our UI as the client. So this is an easy way to test a function, to see if it works, to see if it returns what you want. It's really great for future developers to kind of discover and play with the functions. Next, I'd love to show you how you can bulk import many functions. So how do you train many functions at once if you have an OpenAPI spec? For that, we'll switch to VS Code. I'm going to go ahead and just use the pet store Swagger example. It's something that most developers are familiar with. We won't use these functions, so they don't need to work, but just as a simple example of how to train. For that, we'll run a command like this, model generate, where we specify the file that we want to generate it from. So we'll copy its relative path. You can optionally provide the name of the directory that you want the file to go in. We're just going to leave it blank, and it'll show up at the root. And then there's some additional configurations you could provide as well. So I'll just go ahead and write --help so we could see those. So you could specify, for example, the context they should be trained in, how the host URL should be handled, if you want to hard code it, if you want to treat it as an argument. That depends on how many servers are supported. You can disable the AI from filling in missing descriptions, and you can rename some mappings if you, for example, wanted to do a bulk transformation operation. In my example, I'll just go ahead and add a context. I'll just do demo.pets, and we'll go ahead and run this command. And we'll go ahead and run it one more time without the help. So we could see a spec was generated. Now this is in the poly spec, so I can take a look at it here. This is our schema. So the same schema that powers the catalog, this is what it looks like. I can then next validate it. I can do npx poly model validate, where I provided the new file to make sure that everything was generated correctly. Great, and I can do npx poly model train and the same file. So we could see it found 4 API functions, and it also found 3 schemas. And it went ahead and regenerated my client library, which we'll get to in just a second. So this is the other approach that you could take to training functions if you have an OpenAPI spec and you're happy with the spec. So let's go take a look at what these functions look like in the catalog. So here we are, we're back. I'm gonna go ahead and hit refresh. And you can see that, some of them had really long descriptions. These are the 4 functions. I'm gonna go ahead and click on add pet. Same idea, you could see the source, you could see its arguments. So this one expects just the body. You could also see, for example, a return type schema. In this case, it references demo pets.pet. And you can also go to schemas, and you could see that we have a bunch of these schemas. Some are out of the box, some are my own. So let's go ahead and look at just the environment ones. So here they are. Here's what a new pet looks like. You can also add your own schemas too, or update them here. So if you, for example, wanted to have certain types that represent maybe intermediary states inside your objects, or represent your schema that people should be conforming to when they're programming against it. One approach is to pull those from the OpenAPI specs. Another approach is to just add the JSON type schemas directly into the system here. So with that, I hope you have an idea of how to train API functions. Now let's go to VS Code and consume some of these functions. So I'm going to go ahead and close this out since we're done with the training, and I'll go ahead and hit clear. And now I'm going to play the role of a client developer. So this is somebody who wants to either use your APIs, maybe it's a partner or customer, or it's maybe one of your developers building an integration on top of systems inside your catalog. So as a client developer, one thing I'd like to do is regenerate my SDK to have the latest. So I'll go ahead and run a command like this. There we go. And here I'm basically providing the context that I want for my project. So think of it as there is a global catalog, and then your tenant administrator has filtered that down to the relevant functions that they want your tenant to have, and then added their own. And then from there, you as a client developer can then further filter when you generate the SDKs to just the functions that are relevant to you. So with the generated SDK, we can start developing. And for that, we can use the tree. So for example, if I wanted to use the Google Maps function, I can go ahead and click it. It copies it. I'll say something like import poly from PolyAPI. That's our generated library. Here I could use this function. We could see that, for example, it's got a description, it's got a unique ID, the arguments have names, so these are all AI generated during that training. And then I can go into the function. I could see that it's got a very well-defined type that it returns. I could see that it expects a location and key as strings, and that type has been mapped here locally inside that function. In the case of our pets functions, it's a little bit different. So I can go into demo, pets, and here I could, for example, add pet. Same idea on the description and ID, etc. And then you can go into it, and here, because the OpenAPI spec had details, had schemas that were referenced, you could see that we modeled it as a reference to those schemas. So you can then follow those paths and get to the schemas, but they're declared as their own. And so here, if you want to use a schema in the client, I could say something like this: const body of type, let's go take a look at that. So I think we had it here, new pet, and then that's going to be schemas. So you can actually find it through the type ahead, but you could also look in here. So for example, here's our new pet, same idea, left click, copies it, and I could say I want like that. And so now body is going to be of that type, and so I could say it equals whatnot. And what's nice is that now I have the understanding of what that's going to look like. So for example, here it's just a name and a tag. So you could click name, and you could see, for example, it wants it as a string, etc., etc. So that's one approach. You have the functions, you have their interfaces, you have the corresponding schemas, and you can basically use those. Now the other approach is to leverage our AI assistant to help you get going. So here we'll use the Google Maps function. I'll say something like, do I get location info about New York using Google Maps? And what it's doing here is it's doing a multi-step orchestration. The first step is to extract the relevant keywords and then go ahead and make a call to our catalog, find the relevant functions, get the response, pick the winner of that relevant set, and then go fetch the details for the one or more winning functions. And then lastly, use those to generate an example of how to accomplish the user's prompt with those functions. So we could see it's found not just the function, but it's also confident that that Google Maps API key can be used as one of the arguments. It's also gone ahead and structured it as a new async function, which is something we do intentionally so that you could start building new microservices more quickly. So we got get location info. It's defined it as a void. It's just the starting point. So now let's ask it, I'll say something like, can you modify it so that it returns a lat and long? Please define it as a new interface and log the lat long before returning it. Okay. So you can see it takes our instruction and modifies it, and then it goes ahead and does a check. It understands what assumptions it's making. So for example, it says, well, if there are results, then let's go ahead and create this response object of type lat long. And if there's not, then we want to log that nothing was found and return null, right? And so here we can go ahead and copy this here, and we can go ahead and paste it. And in my situation here, I'm going to make just a couple little tweaks. So I don't want to accept lat long to have to just return null. That might break my system. So I'm just going to go ahead and return a 0, 0. So let's just do something like this: latitude 0 and longitude 0. Right? And so what I'm trying to demonstrate here is that you as a developer have full control over this code. So just because it was AI generated doesn't mean it's not yours. It's just an accelerant. So here we are, we've got this function, we're happy with it, and this is an example of what I as a client developer might be doing to get to a point where I'm happy with using this code. You can also strongly type it. So for example, here it's implicit. So you could see that it's using this generated type. So I can also, for example, strongly type the response, and then I can import that schema. So you have the ability to work with types to make sure you're adhering to type safety, etc. So let's go ahead and run it. We'll just do something like this. grab this file. And we can see that we're getting a log statement with the latitude and longitude for New York. And you can go take this further now. So you could say, for example, there's some slash commands. If you're ever curious what they are, /h will give you the different slash commands. And so /g is basically to like bypass Poly. If you're ever just dealing with general programming, general questions, and you don't want it to do that orchestration against the catalog. So I'll just say something like /g, generate a few more tests where some of the locations don't exist. So it gives us our code back, and it gives us a set of tests. So I'm going to go ahead and borrow these tests, and then we'll go ahead and run them. So again, super helpful. You can see it's got Gotham City, it's got Atlantis, but it might find Atlantis Resorts or something. So, and then random non-existent place hopefully totally fails. So let's run this again. Cool. So you can see that Atlantis was not found, Gotham City was not found, Sydney was found, and then random place was not found. So I would say our service is working as expected. So next up, we can now deploy this as a microservice, but I want to introduce one more step in between. Because this could be the beginning of a general mapping service that maybe checks multiple data sources, or maybe routes based on cost, or maybe routes based on location, or maybe routes based on the intent of the caller. I'm going to use this as a client function, as a kind of a reusable function, and then I'll put that client function inside a microservice that has the ability to control that routing logic. And again, you might have your own logic as to how it routes. You could say that first check one, and then if it's not found, check another one. Or you might say, hey, let the user pass an argument that tells us which one to use. So this is just a demo. So to do that, I'm going to go ahead and comment out this test code, and I'm going to go ahead and deploy this function as a new function to the Poly catalog. So I'll say npx poly function add get long from demo.client. Oh, actually, you know what? Sorry, let's do this. Let's go ahead and copy this code into a new file. Let's do demo client utility function. And then let's go ahead and continue here. The reason is I just want to keep my demo client file as always representing the user. And in this case, we're now, I should have pointed out, switching hats to somebody building a service, an integration service using Poly. So we specify the file it's from. And Poly can always help you out too if you're ever interested in how to do things. Like you could say, /p is Poly questions about documentation. So you could say something like, how do I deploy a TypeScript Poly function? And this will search our documentation and give you an answer. So you can see it's got some steps to get there, some steps on how to write it, and it gives you the command here that I'm using. So this is super helpful because you don't want to have to read our documentation. You can just ask questions about the documentation to Poly itself. So we'll go ahead and emulate this function right here. So that's where it's from. The context, we'll say -- context, and we'll say this is going to be demo.client functions. And then you get to specify if it's a client function or server function. So here's an example of a server function. In my case, I'm going to go ahead and do it as a client function. I'm confused about the concept. Again, just showing Poly. What is the difference between a client and server function? And so again, searching the documentation, you can see it's got a nice description for you. Blah, 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 example, server functions, example. So in the interest of time, we're not going to go through that, but just note that Poly is always there to help you if you need it. So we'll do -- client, and we'll go ahead and copy it, and we'll go ahead and deploy it. Oops, what did I copy? There we go. And while that's deploying, the only thing to really note is client functions are packaged into the SDK, so they execute client side, meaning that the code is bundled into the SDK. They're meant to be used within the client application. A server function gets its own container, its own runtime. It's managed by Knative on top of Poly, so you can think of it as its own serverless function. You can use client functions inside server functions, which is what we're going to do, and you do this for reusability. The real power is that you could still change the code of the client functions, and the server functions, next time they wake up, will pick up that client code. That means if you have, say, 30 server functions leveraging the same client function, you can fix it in one place, go through your deployment pipeline, promote it to production, and then next time those server functions wake up, they'll pick up the latest client code. So we can see we got a new client function. Let's go take a quick look at it in the UI. So here's our client function. You can see its code. You can see a name, a description was generated for it, its name, its interface, and then you could also see what arguments it expects. So it expects just the location, and then you can also see the return type schema. Didn't get built, so let me take a quick look here. Oh yeah, that's right. At this point, we do have a bit of a limitation where we only support one type, and so that's why that schema did not get built. That's something we hope to fix in the near future. So I'll just go ahead and redeploy it as one more time. Okay, we can see the ID is the same. So we'll go back to our UI, refresh, and this time it's got a type schema. So now that we have this reusable client function, let's go ahead and write a server function which uses it. So for that, I'm going to go ahead and close some of these out. And we'll open up our demo service. I'll import Poly from PolyAPI. And we'll do something like async function location service. We want the, for example, provider ID, and that's going to be a string. And then we want, for example, the location, which is also a string. Okay, and then we're going to promise we're going to promise back a lat long. But let's go ahead and use the type that was defined in that client function. So generally you would do this the other way around. You would define it in the server function, and then you'd use it inside the various client functions. I'm going to be a little bit lazy. I'm going to go ahead and just borrow that type. So to do that, I'll actually go ahead and grab my client functions here. I'll drop it in here. We'll go grab that type. And then I'm going to go say that we're going to actually promise you that type. Okay. And then let's see here. I'll go ahead and close the terminal just for a second. We'll import demo. And then we'll say something like if provider ID equals Google Maps, then let's go ahead and do return that client function. Oops. Okay, and then else provider ID. Oops, actually we'll just do an else without a provider ID because we don't support any other providers at this point. I'll do a console.log requested provider not found, and we'll do something like this. Okay, and then we'll just go ahead and return a empty object. So lat 0, long 0, and we'll go ahead and do that. And then we don't need this one anymore if we're already using it. So this is an example of that microservice that can straddle, and again, you'd add your own logic as to when you would use which provider, but just an example of a server function using a client function that we created. And same idea on the deployment. I'm gonna go ahead and, oh, actually, let's go ahead and do this. Let's go ahead and console.log Google Maps was used. Okay, so we can see a log statement. Now you generally wouldn't just do a straight return. You want to do a log, but I also do want to demonstrate that anything that's logged inside the client function will be logged inside the server function. So we'll see this log statement inside the logs of the server function where it was used. And that's also super helpful. So same idea here. Let's go ahead and deploy it. Function add location service from the demo services file. And I'd like to just write these out so I can copy paste them for easy deployment, so I don't actually accidentally, fat finger something and deploy the wrong function or deploy a duplicate, etc. So this is just cleaner. So I'll just say context equals demo.services. I will make it a server function. And we'll go ahead and deploy this as well. Great, so we get a new function ID, same idea. Go back to the UI, under server functions, you can see the location service. I forgot to turn on logs, so I'll just go ahead and flip it to true here in the UI. Logs are off by default. We'll hit submit. And here we can actually execute this function directly now. So we'll go ahead and copy this provider. And then we'll say location, let's do something new, Miami Beach. Okay, so we can see we're getting a latitude, longitude. And then we can go to its logs and we can see that Google Maps was used and then the latitude, longitude. Now let's try for a provider that does not exist. So we'll go ahead and hit execute. For location, we'll say, and then for the provider ID, we'll just say foo maps. And we can see we're getting a 0, 0. And if we go to the logs, we can see that the request provider was not found, foo maps. So we have this microservice, it's now working, it's now usable. So one thing you could do is you could always trigger these microservices through the UI. Or if you're a client developer, you can use them in the code. So here we are back in VS Code. I'm going to go ahead and clear my AI, and I'm going to say, how do I get lat and long for a location? Or let's do address, just to throw it off a little bit, because we've been calling everything a location, and this time we're going to use an address. So you can see that it found a couple of options. So we've got the client function it found. We've got the Google Maps function it found. But it didn't find the server function in this case. So it just depends. It gets a little bit tricky when you have a lot of choices and they're all valid. It tries its best to pick the best one. So I'm going to give it a little bit more of a guided tour. So I'll say, what server function can I use for location searching? Okay, so we can see it found demo services location service. So if you are somebody that has a lot of functions that are kind of conflicting or potentially competitive, it could get tricky. The AI will try and pick the best one, but at the same time, there is some limitation there around finding the exhaustive list. You could ask it to give you the full list, etc., but with a little bit of nudging, it did find the right function for us. So I'll go ahead and use that in our demo client. I'll delete all this code. We'll copy this. We could see that it understood the type, and it basically went ahead and redefined it. In the future, we're also going to make it so that it basically just uses the type instead of re-instantiating it. So I think there's a little bit more room for improvement here to make this code even tighter, because you can see that it promises, coordinates here, which is a new type, whereas we could just promise the response from the result. So we can, ideally the AI should do this, in my opinion. But there's maybe a healthy debate to be had there. So let me go ahead and do this one more time. Go ahead and copy this, replace it here, and then we'll get rid of coordinates, and then we'll do something like this. Okay, so in my opinion, this would have been a more perfect answer. So here I am, client developer inside my client, and I want to do this. Again, this could be cross-language, so it could be a Python client consuming a TypeScript server function or vice versa. So there's no limitation. All these server functions are available in all languages that are generated. And we'll go ahead and clear this, have a little more space, something like this. So this one fails, remember, because Google Maps is not valid. So we'll do Google. And I should also point out that we could have defined this as an enum type, and then it would have been clear in the generate type. So that would have been one way to make this demo maybe a little more above and beyond. But hopefully you still get the idea of how this works. So that's server functions, using a client function, using API functions that we trained. The last thing I'd like to show you is how you could expose this as an API. Maybe your partner or your customer or the consumer of this won't use it in native TypeScript, Python, and Java. Maybe they're not comfortable using the Poly SDK for a reason, for a valid reason. So let's say we want to create a new endpoint that's publicly available where you could invoke it and use the same server function. For that, we would have to change our demo service just a little bit. It has a strict interface that it expects, and we have examples of how that looks like through a feature called snippets, where you could go to, for example, PolyAPI, and then we have, for example, server functions. And so we have a server function template, and more specifically, we have a snippet that allows you to understand how to structure a service so that it could be linked to a webhook. I'm going to go ahead and copy this snippet and paste it. And you have the ability to add and publish your own snippets too. So if there's reusable blocks of code that don't make sense as functions, you want to just have them be snippets, and you want to make them easily available to your consumers or to the developers on your team, you could use the snippets feature for that. So specifically, the interface we want is this. We want an event headers params. You should typically define this. I'm going to go ahead and copy these. I'm just going to go ahead and delete all this. And so what we want is basically this right here. And then we want this to be a new interface. So I'm just going to use the AI to make it faster. Again, showcasing how I like to use the AI. You're welcome to write this all by hand. You're welcome to use the AI. So I would say declare new interface, and then we'll say this one should be type with new interface, and we can keep these two as any. Okay, so I'll go ahead and copy this, and you could use GitHub Copilot Chat too if you prefer. You don't have to use the PolyAI Assistant. We are one of the first 24 extensions to GitHub Copilot Chat, so if you already use that, you're welcome to use Poly through GitHub Copilot Chat. I'm just going to say address these comments. Okay, so it's defined a new interface. It's typed it. It's made these, headers. So it actually took one step further and kind of made params and headers a little bit cleaner. And then basically, gave us this function here. So let's go ahead and copy this. Go ahead and replace all that. Let's double check just to make sure we're happy with it. So interface is good, event is good. It's going ahead and using that. Location, it's extracting provider ID and location, and it's already updated the code to continue to use it correctly. We don't need this example, so I'll go ahead and get rid of that. And then we're just going to head and redeploy this one more time. So again, some people like AI for exactly this. Others don't. No strong opinions. Use it if you find it valuable. Don't use it if you think it's easier for you to just type it all out. Great. So we can see that same function ID. It's been redeployed. And so now what's going to happen is most likely our client is going to complain because this is no longer the right interface. So as soon as the TypeScript server loads it, you can see it's not happy with this. It expected 3 arguments. It got 2. So what we want to do is go ahead and basically pass these 2 in. So I'll just make it something like this. And then we'll say undefined, undefined, and we'll go ahead and test it real quick one more time. So our function is still working as expected, just a slightly different interface so that it could be linked up to webhook records in Poly. So let's go back to the catalog and define a new webhook event and go ahead and link the 2 together. So here we are. We'll go to webhooks. We'll say we want to create a new webhook, and we'll say something like location, or let's say on location search demo dot, let's say APIs, something like that. We'll let the description be generated. The event payload, let's just make this a get, so it'll be easy to use. We'll do get. We could specify a custom slug for the URL, so let's say locations, and then this is the slash path. So the subpath is going to be like, let's say locations slash, or actually, sorry, let's call it mapping. And then subpath is slash locations. I'm going to go ahead and opt out of requiring a PolyAPI key just to make it easy to use via the browser. But you could also set it to require a key, or you can route it through a security function. And the security function is basically a server function that assesses this incoming request, decides if it should go through or not. And so that's where you'd introspect OAuth tokens, validate keys. Like there's a lot of stuff you can do in there to decide whether the server function that we developed should even be invoked. In this example, I'll skip that. It'll be wide open to the internet. I'm going to go ahead and delete it after this demo, but you get the idea, just to keep it simple. And then we don't have a fixed response payload or headers or status code or anything, so we'll just go ahead and hit submit. Okay, so now we have a webhook. And the last piece is to basically have it so that that webhook triggers the server function. So we'll go ahead and create a new trigger. So let's say locations trigger, source webhook. I'll pick the location search. For the destination server function, I'll pick the one server function we have here. And I'm going to say that we want to wait for a response, which means that the Poly gateway, when it receives this request, is going to hold on to the session till the server function responds, and it's going to give a response back to the client or the invoker. If you set this to false, it'll basically trigger the server function. It'll kick back the status code that it was defaulted to, and it's going to say, hey, message received, we're good. So you have both choices depending on your use case. So we'll hit submit. And now we should be able to actually invoke this webhook. So you could use Postman, you could use our UI, you could call it from your code. I'll just go ahead and use our UI here. I don't think we have a required payload event. Oh, actually, sorry, I realized I forgot one important thing. We need to go ahead and update it. to get, I realized we do actually expect an event to be passed in, so I should have made this a post, and I set it as a body. We could have done it as a parameter using the subpath, but that was just an omission on my part for the demo, so we'll just roll with it. Let's say we want this to be a post. Maybe it's representing connecting some legacy system or something that requires it that way. But I really should have added it as template params inside this subpath. But anyhow, this will work as well. So we'll go ahead and say trigger. Here we need that event type. In the future, we want to make this also schema aware, but it's not at the moment. So I'll go ahead and copy some of these from here. We'll go ahead and do something like this. We'll do Google Maps. And then we'll say, let's just do Seattle. Okay, so we can see we got a 200. We could see the data. It wasn't found. So we could take a look inside the server function to see what happened. All right, well, I did a little bit of research. I figured out what's going on. We have a little bug with this control right here. So the triggers actually get treated as undefined. I took a look at it inside the logs, and so you're getting basically undefined. So a little bug on our part, we'll get that fixed. But I also did test it in Postman. Same idea, same request, and we could see this one's working just fine here. So anyways, with that, we've got a live demo or live API now as part of this demo, open to the world, where you could pass in a provider ID, a location, and get latitude, longitude information. So hopefully this is a good introduction to Poly. There's so much more we haven't covered. We haven't covered a ton of stuff, but hopefully this gives you a good introduction to what our service is capable of and how you would use it to build integrations, new microservices, new orchestrations, new APIs, how you would create an API to abstract away different providers. So there's definitely 5 core use cases. I'd encourage you to go to the website, learn more about them. We're doing a detailed write-up for each of them, so you can really get some good information on how to use these concepts that I've shown you to accomplish your use case. With that, thank you very much, and have a great rest of your day, and we hope to talk to you soon.